Okay, so here we're going over problem number 2, which is to expand these expressions as much as possible and then combine like terms. And so it looks like most of these is just going to require multiplication. So let's go ahead and do one of these. Let's start with part A. And essentially, wherever you see a set of parentheses with a number in front of it, you can just distribute that number into the terms inside of the parentheses. And so we have 4 times 3x, which is 12x, 4 times a minus 1, which is a minus 4, and then there's a minus 7 outside that we can just carry over. And then now we can combine like terms. The negative 4 and the negative 7 are like terms, so we combine those to get negative 11. So we have 12x minus 11 as our answer. Okay. What do we do if we have, a set of parentheses next to another set of parentheses? Well, what we really should do, so let me show this a long way, I guess, is multiply this entire set of parentheses into the first term, 2x, and then again to the 5. So here we would have 2x times the x minus 3 plus 5 times the x minus 3. I distribute that x minus 3 to each of the terms, 2x and 5. And then there's a minus 6 that I'll just carry over. And notice that this now becomes the same distributive property problem that we had in the previous example, there in blue. And so we distribute the 2x. That's going to give us, and I'll do it below here, 2x times x is 2x squared. 2x times a minus 3 is a minus 6x. Plus 5 times x is 5x, and minus 15 minus 6. Combining like terms, here we have like terms of negative 6x and positive 5x. Those are like terms because they have the same variables with the same exponents. And then negative 15 and negative 6 don't have variables. So those are just constants, so those are like terms as well. So if we combine those, we get negative 1x minus 21, and that's our answer. We can't combine any further. I have seen students try to combine these two terms. That's not possible with addition or subtraction because they are not like terms. They have, let's say the first two terms that there's an x squared, x to the second power, and the second term has an x, but not to the second power. Okay, so next, negative 2 times x plus 4 times x minus 2 plus 5x. How can we do this problem? Well, in the first set of parentheses, we have negative 2 out front. So I will distribute this negative 2 to that first set of parentheses. One common mistake that students think is that they can distribute this negative 2 to both of the sets of parentheses, and that would be incorrect. We should multiply to only the first set or the second set, either one, but not both. I think it's most natural to distribute into the first set of parentheses, so I'll do that. Negative 2x minus 8. Now, this would still be in parentheses here because we're multiplying three factors, and the factors are negative 2, x plus 4, and x minus 2. So once we multiply the negative 2 to the x plus 4, that is still a factor itself that needs to be multiplied with the x minus 2. So we're going to multiply with the x minus 2. And you've probably seen the FOIL method, which is what I'll use in this problem. That's where we just distribute the first term, negative 2x, to the x to get negative 2x squared. Negative 2x times a negative 2 is a positive 4x. Then the inner terms, that's minus 8x. And then the last terms, negative 8 and negative 2, give us a positive 16 when we multiply them. And now we combine like terms. We get negative 2x squared. Let's see, 4x minus 8x plus 5x. We're going to combine all of these terms. Those are like terms. That is negative 4 plus 5. That's positive 1x plus 16. And that's our answer. Sometimes students wonder, sometimes students want to multiply the two binomials, x plus 4 and x minus 2, with each other at the beginning. That's perfectly fine. That would work out the exact same way. I'll actually do it here in red. Negative 2 times x plus 4 times x minus 2 plus 5x. This is one of the nice things about this class, about math in general. Usually there's a whole bunch of different ways to do the problem. So x times x is x squared. X times a minus 2 is a negative 2x. 4 times x is positive 4x. And 4 times a minus 2 is a minus 8. Now we'll distribute the negative 2. Gives us a negative 2x squared, a positive 4x, negative 8x, and a positive 16 plus 5x. And what do we have? A positive 4x, negative 8x, and a positive 5x. It would combine to be the same answer that we got before. Okay, so that's pretty nice. Yeah, so we get the same answer. And finally, let's take a look at the last problem. 2D. This is 2x minus 3 times an x plus 6 plus the square root of 5. And so, okay, we'll do the distributive property using the FOIL method. 2x squared plus 12x minus 3x minus 18 plus square root of 5. And so what are the like terms here? The like terms are these two terms, 12x and a minus 3. So we have 2x squared. And in a sense, you could say, maybe there's a way you could say that 18 and square root of 5 are like terms. They're both constant terms. But you may have seen algebra with radicals in the past. And so we're not actually going to be able to combine 18 and square root of 5. If you had something like 18 square root of 5 plus 3 square root of 5, that could be combined because they both have the square root of 5, giving us 21 square root of 5. So you may see some sort of algebra that goes with that. But in this case, we don't have a square root of 5 in one of the terms. And so, this would not be simplifiable. So our answer is 2x squared. We can combine the like terms of 12x and minus 3x to get 9x. And then we'll just leave minus 18 plus the square root of 5, just like that. All right. So, yep, that's it there. I will stop the video and then make a separate video for the next problem.